And we're back with more on Chapter 9, which is, again, one of the most important chapters we've had because it's the one where the weather map actually starts to make sense. And there are a couple of things in this chapter I want to sort of get out of the way that need mentioning, but I'm not going to dwell on them a lot, so I'm going to go ahead and talk about them. One is, if you recall, we talked about polar front theory. Like, do you believe in fronts? It's just a theory. Well, yeah, it's just a theory to believe in fronts, but I do. But about 2 or 3 editions of the book ago, they put a new section in, and honestly, it was something I never heard of before, called the conveyor belt model. I actually had to learn about it in your book, because as much as I've been into meteorology my whole life, I never heard of this before. This thing right here, where instead of believing in fronts exactly, or in emphasizing fronts per se, there's this idea that there are these conveyor belts of dry air and cold air and warm, moist air, and they like overlap each other in various ways. It's a useful mental model. I'm not used to using it. I should learn more about it. It isn't talked about, though, as far as I can tell, nearly as much as fronts are. It's sort of an academic thing at the moment with some insights to be had, but we'll kind of skip it. Take a look at the book because it's interesting that you can think about these things a different way. Another issue that I want to talk about kind of briefly is this thing about where mid-latitude cyclones form in a practical sense. Now, of course, this section is unique, at least that picture is unique, to North America. And it's the places where you get these things, where there's patterns that are conducive to their formation. First of all, and I'm not going to draw it myself. I think I'll just show. We have, they form off the Pacific coast around Washington, British Columbia. That's a nice place for these low pressure systems to really get cranked up. They also tend to be given birth to, in say Alberta or all the way down to Colorado. And the 2 places I think about the most, actually, the Gulf lows, lows forming the Gulf. That's a big thing here in Atlanta. And also these Hatteras lows. Let me talk a little bit about the history of these things. First of all, I don't think much about the ones off Washington, Oregon, because that's, they affect them a lot. And that is a place where the subpolar low gets real intense a lot of times, and we get lows there. The Colorado area, something to do with the mountains, not quite sure what all. It's kind of worth talking about the Alberta one. I went to Alberta last summer. It was a nice trip. Went to Lethbridge and Calgary and to the Banff and all that kind of stuff. But anyway, low pressure systems form up there because the way the jet stream comes over the Rockies and so forth. And there's a type of low pressure system that forms there called an Alberta clipper. If you start watching the Weather Channel a lot or whatever weather broadcasts in the winter especially, every now and then you'll hear about an Alberta clipper, a clipper system. An Alberta clipper was a ship, a really fast sailing ship. And so Alberta clippers are famous for moving fast, and they tend to come flying down out of Alberta down into the United States. They sweep through really fast. Usually it's in the winter. It snows. Some cold continental polar air comes in behind them. We get the little brush tail end of them a little bit. So that's Alberta clippers. The Hatteras lows, those things are sometimes there's this thing called bomb cyclogenesis. Now, cyclogenesis, that's a good word. Cyclogenesis. I'm going to write that. I like that word so much. Cyclogenesis. I think you can figure out what it is. It's the birth of a wave cyclone, and a cyclone is just a low pressure system. And they tend to form very strongly, especially in winter, out off Cape Hatteras. And they go up the East Coast and become a nor'easter. I didn't say that right at all. Bad Boston kind of accent there. But they get them up in the Northeast, and it's a big deal for them. Get them also in Eastern North Carolina, D.C., up that way. And the reason is because you have huge contrasts. The very cold air in the winter over the continent of the United States, and then the Gulf Stream right offshore, you have serious contrast. And about the whole thermal socialism thing. When there's a big contrast, the atmosphere just can't stand it. It just has to redistribute everything, get spherosity going there, and bomb cyclogenesis. But the one I really want to talk about just for a moment is the one about in the Gulf of Mexico. Let me talk about that for a second. Here's Georgia, you know. Oh, God, it's not reading Georgia. Not my best. Anyway, Georgia and Alabama, and there's Florida down here. In the winter, here's what happens a good bit. But it's exciting when it does. Sometimes really cold air will sweep down into the country. At least continental polar, maybe Arctic. Continental Arctic air will sweep in. And the cold front will get down to about here. Right on the border between the boards, I guess. And it'll tend to stall out. And so it's real cold here and real warm over the Gulf of Mexico. And that huge contrast is a source of a lot of energy, a lot of potential energy involved with that. You get a nice subtropical jet running across it, and you will develop cyclogenesis. Remember we showed the polar front theory? Except usually you're thinking of it being up like around the U.S.-Canadian border, you know, where the polar jet stream usually is, and that's kind of the classic picture. Now I'll do something in the northern United States for the example I gave you. But here, it happens much further south where the subtropical jet stream's coming along. And so you get this low pressure form in the Gulf of Mexico. And when cyclogenesis occurs in the northern Gulf of Mexico in winter, that low tends to track this way. It tends to track across like northern Florida, southeast Georgia, and leaves us in the cold air. And yet, out ahead of the low, clockwise, high north, counterclockwise, low north, we get warm air flooding up over the surface up at high altitudes. And that's our big ice storm and snowstorm situation. The circulation around the low brings air in from the northeast. Sometimes it's the wedge. You can tell I'm excited because there's been a lot of winter weather events here, you know, that were big deals when we had low pressure form in the Gulf of Mexico. I might refer back to that again sometime. By the way, that same low sometimes tracks across Florida, loses a little bit of its punch, but when it finds the Gulf Stream out here, that warm water, it just blows up, bomb, cyclogenesis, and then it becomes a nor'easter. Hits them harder, it hits us, you know. Anyway, that's some about where these things form. What I want to do now, though, is two things. To pick up on where I sort of left off just now with where these lows form, I want to talk about conditions that are conducive to them forming. When I was interested in the weather when I was younger than you, I was probably like 12 to 13 years old, it was a mystery to me. Like, how did you know a low pressure system was going to form? Why would it do that? How do you know the atmosphere is going to want to do that? Well, some of it was contrast, but some of it is what's happening up high in the atmosphere, up above it. Let me show that just a little bit. If you have, and the picture in the book's actually a little, this chapter, chapter 8, there's a picture that's a little confusing the way it's shown. Well, let me just show the part I want to show. If you have a jet stream or upper air pattern with the isobars looking like this, say, like that, notice this. Over here, under a ridge of relatively high pressure over here, again, this is fairly geostrophic, kind of winds fog these contours. Notice that the air is being smashed together at high altitudes. It's converging. When you bring air together over some poor soft down soul down there, when you bring air together over them, you're piling it on, and when you pile it on, they're under pressure. So you tend to get at the surface, I'll make blue for the surface, this is upper air, you'll tend to get high pressure forming at the surface there. But over here, you see where everything's spreading apart? That is the suction effect. You're like taking air away from on top of that region. So in the southeast quadrant, sort of an upper level low, you tend to get this divergence aloft, and you tend to get low pressure form at the surface. And moreover, the low pressure probably travels and tracks this way, while the high pressure travels and tracks that way. There's this sort of like thing going on a lot of times, where high pressure dives down out of the northwest, hot on the heels of low pressure scooting off to the northeast. That's just kind of a thing in the mid-northern latitudes, especially around here. So I thought I'd show that. That's, again, another factor. Convergence aloft, meaning up high. tends to produce high pressure at the surface, and divergence makes low pressure. So that's one of the magic tricks that meteorologists knew even before they had computers figuring it all out for them. They knew that trick. Okay, so those are factors affecting the likelihood of cyclogenesis. Now, the thing I want to do next is to put it together in a practical sense, and sometimes it gets super practical. Last night, today is April 13th, and last night there was all these warnings about big old storms coming through, and I was somewhat concerned, and I set my alarm for, I looked at the high resolution models online last night and saw that the line of storms was going to come through between 2 and 3 o'clock or so. And I was concerned. There was a big chance, they were saying, talking all about it, about severe weather. And there was a tornado watch. And so I set my alarm for 1:45. Woke up, looked at the radar. Line appeared to be breaking apart. I was kind of put at ease a little bit. Didn't quite go back to sleep, though. I was kind of a little bit wary. The dog was pacing around, so I'm kind of listening. And I heard sort of a long, protracted rumble of thunder that just kind of went on for a minute or two. And I was kind of wondering what it was. And then I hear a siren going off. And it's like, yep, I know what that is. So we got the dog. Oops. Well, I'm in the bed. Sorry, comment. Anyway, we went down to the basement, but it was weird. Nothing was going on. Then everybody we know starts texting us and calling us, and it's like, are you okay? You okay? On the radar, the tornado came right over us, right over Woodward Academy. And I can't seem to find the damage. I'm waiting to see the news, see who. I saw 2 trees down within 2 miles of here, and that's it. Didn't do much here. But that was along a cold front, and I could tell the cold front was coming because of those strong southwest winds that were so warm and humid ahead of it. In other words, I want you to get a feel here for what the patterns are with frontal passages, because that's what life is kind of about, at least during the more exciting times of the year, here in the mid-latitudes. So, a couple of ideas. A reminder, first of all. You'll recall, I hope, how am I doing on this time here? 12 minutes, we're good. Okay, so remember, clockwise high north. Remember, if you got high pressure, the wind at the surface tends to, and this is northern hemisphere, spirals out from it like that, whereas low pressure, it spirals in. So one thing you want to have a mental image of is which way the wind would be blowing if a higher or low pressure system passed by you. I regret and lament not bringing a certain thing home with me. It's called the weather cycler. It's this cute low-tech thing consisting of some cardboard, a sliding thing, and some plastic and some little windows in it. It's so clever. Somebody probably got a patent on it, but it's a great meteorology teaching tool. Oh, you'd learn so much if you held it in your very own hands and played with it. I'm going to have to sub for it as best as I can here, so listen closely. Maybe I can talk more on Zoom about it without my weather cipher. What if, let's say, some low pressure passed to our south? Okay, we live here, let's say, and here's a low pressure system passing to our south. On one day, isobars look like that. Oh, I know, color code. It's going to be so nice. Then it looks like that, the next day, because it's moving, because they do that. And then here's maybe the next day, the low's over here. I want you to visualize what the wind would do here in Atlanta as a low pressure, maybe one from cyclogenesis in the northern Gulf, happens. First of all, the wind circulation around the low would be like this. So at first, we would have winds coming out of the east, southeast, east-southeast, kind of like that. And you'd walk outside and you'd feel the wind blowing on you that way. And then the next day, that's going to be the blue day. I hope you can understand my color coding here. On the next day, you see the low is south of us and the wind is spiraling into it. So the wind has now started coming out of the northeast. So you walked outside to stand with your face into the wind. And at first it was out of the southeast or something, east-southeast. Then it shifted around and was coming out of the northeast. And look what happens once it's passed. Once the low has traveled off to your east, now the wind sucking into it like that, spiraling in, is coming out of the northwest. So the wind went from, I'm going to be cutesy color coded here, went from like east southeast to, what's that? To like northeast to, yeah, I'm happy with my little color coding, northwest. And if you stood outside the whole time with your face into the wind, you would find yourself rotating to keep your face into the wind, so you like the wind in your face. You'd be turning around like this, and you'd be turning where it's turning around. That's counterclockwise, as seen from looking above your head. In other words, it's moving around to your left. This kind of wind is called backing. When the wind changes in this way so that it goes from, say, east to northeast to northwest, and you have to turn to your left, that's called a backing wind. And if the wind is backing, it's an indicator that the low is traveling to your south. It's going to pass by to your south. If it passes to your south, the wind will never come out of the south. It'll stay out of the north, and you'll stay cold, which can be important, like in the winter. See why it could snow then? Because you can get the low pressure makes rain and stuff, and then it goes to your south and you stay cold. But what if the low passes to your north? What if a low does this? It's there. I like my color coding. Then it's there. And then it's there. It's got these, like that kind of stuff again. And yeah. And then this. All right. What direction is these winds going to be from? First of all, the wind's spiraling counterclockwise, and the low is probably coming out of the south. So we have wind out of the south at first. Then as the low gets north of you, it's probably coming out of the west. And then once it gets past you, it's kind of sweeping in like this out of, say, northwest. If you stand outside in that, you will find yourself turning clockwise as seen from above. You'll be turning to your right. So that is called, that's when the wind goes clockwise, and it's called veering. If the wind veers, it's going to shift, so you have to turn to your right to keep your face in it. And if you want to be kind of weather-wise, and without even consulting a map or checking online or whatever, and you want to just like pull dirt up and drop it like in that Twister movie, or watch the animals. I saw a squirrel, the way he was eating. Maybe it's a weather thing. I don't know. But if you want to be weather-wise, you watch the way the wind changes, and you can tell what's going to happen. Now, if a low passes to your north, actually, I could have done the same thing with high pressure. Try it yourself. Draw your little H's and your little things and move them on by. You'll find the wind also backs when, let's see if I'm saying this right. I better check. We're going to make a high pressure system pass by. And here we are. I'm going to make a high pass by to the south. So here's that, and here it is like, it's going to go from, say, the wind being out of the west, and then the wind's going to be out of kind of the south, and it's going to be kind of the southeast. What's that? That's backing. Oh, yeah, when the pressure center passes to your south, I guess the wind backs up. Is that right? Yeah, that's right. That's right. Okay, so anyway, recall that according to polar front theory, low pressure system forms along fronts. Now the first stage of it is going to be a fairly stationary front with a low pressure just getting started on it. The end stage is going to be a low that already made an occluded front, and it's already about died out, and maybe there's another one back here that's all kind of wound up. I want to look at sort of a young, mature, almost middle-aged low-pressure system. One that's not all the way wound up yet, but it's got its act together. It's going. It's doing some stuff. And here's what it's going to look like. It's going to be like this. There's going to be a low-pressure center like that. And just like last night, there's going to be a cold front trailing it, coming around like that. And just like yesterday, a warm front had passed. Now, I could have an occluded front, too. I won't do the occluded front right now, but isn't that pretty? It's called a wave cyclone, a mid-latitude wave cyclone. So what I'm going to show here is that out ahead of the front, the circulation counterclockwise around the low is bringing up warm air like that. See that warm air coming up like that? Now what you get with the front is a fairly dramatic change in the wind direction. Look at this. Classically, if you live here and this low is passing to your north, you probably had the warm front come through like yesterday, and you're in a place called the warm sector because it's warm all through here, like maritime tropical air from the Gulf. But you're going to have this cold continental polar air blasting in out of the northwest. I'll even say what the air is called. Yep, there's my airs. And actually, out ahead of it, the wind was probably from the east like that. That's kind of the whole picture. In fact, to tell you what, I'm going to be kind of like that weather cycler. What I'm going to do, it's going to be hard for me to draw this over and over again and not make a mess. So what I want to do is I want you to imagine traveling with the frontal system in the low and passing by Atlanta. So I'm going to draw Atlanta at first here. Now, I know Atlanta doesn't move to the west, but I think you get what it's a lot easier for me to move a dot than it is for me to move my picture. And that's what the weather cycler does. Oh well. So what's going to happen is on the first day of this picture, in scene number 1 here on day 1, we are in some old cold air. It's not in the warm sector. It's old cool air, probably with some, it was probably some old continental polar air from a few days ago. It's been kind of lost its accent a little bit. It's kind of cool air now. And look at this. You're out ahead of the warm front, so it's still sort of cool here. The wind is probably from the east. See that? Maybe southeast. It's probably getting cloudy, at least cloudy, because it may be raining. Because what's happening is, remember the conveyor belt picture? Maybe it is kind of useful here. The warm air from the Gulf of Mexico is encountering a wedge of cold air that's kind of shaped like my hand's doing here, and it's riding up over. You get the 3D from what I do with my hand. See, here comes some air. It's like, whoa, and it has to go up. Not as steep as that, but you get the idea. And when it does, it makes clouds. And the first clouds to show up are thin, high clouds. Remember the cloud classification scheme. These will be cirrus clouds. You'll start with cirrus clouds. They'll thicken up to cover the sky and become cirrostratus clouds. They will then get even thicker, and the base will get lower, even though the top kind of stays up there. The base gets lower, which means they get thicker, and the sun gets more and more dimmed out, and they become altostratus clouds, which are mid-level bases, and you can't see the sun too well. You kind of see where it is. And then they lower down even more and become nimbostratus, which means it's raining. Yeah. So you get nimbostratus. It rains and rains. And you think like, oh gosh, this is so depressing. It's raining. See, the clouds are out to here. It's raining. But then you're so weather-wise, you go tell all your friends and neighbors, don't worry. It's always darkest before the dawn. This rain, trust me, it'll clear up. In the morning, you'll be in a whole other world of air, maritime tropical air. And you know what? You turn out to be right because the warm front passes you, and now you're in the warm air. Now you're like here. You enjoy a day of balmy taste of summer. Maybe it's this time of year, like yesterday. It was kind of, last night it got warm. We weren't in the warm sector very long. But anyway, warm air is flooding up, and the clouds probably clear up. It might have been rainy and foggy and cool right there, but as time went by and you became this place, as it went this way, now it's warm. It might be partly sunny, kind of like it is out there, but we're behind the cold front. Beautiful warm day. Then, when you have a big slab of cold air coming in like that, ramming into air, pushing it up like that. Sometimes right along the front, there'll be rain, storms. Sometimes they're a little bit behind it. But actually, it kind of sends out shock waves out ahead of it. Sometimes a thing called a squall line or ripple in the atmosphere of disturbance the front's coming, and it's like advanced troops or something. And you'll get this line of severe storms sometimes out ahead of it. Bad storms coming. This happened last night. The actual bad line of storms was just ahead of the front. There was a little band of showers lingering back right along the front in this case. So the front came through. But by this morning, it was all clearing up because look who Atlanta was by then. We were these people. Now I'm going to go out for a walk in a little bit after supper, and it's going to be so nice. I'll probably wear shorts though because I'll probably get my blue jeans on because it'll be kind of cool because we're now in a springtime version of continental polar air. We're a little on the cool side. Not bad though, quite nice. Nice and fresh winds from the northwest. What happened to the pressure pattern during this sequence of events? Well, the pressure is almost always lowest right along a front, either a warm or a cold front. The pressure is low. So if pressure is dropping, a low pressure system and or its associated fronts, warm or cold or even included, are going to be probably approaching. So you watch for a dropping pressure. The wind direction, as you can see, it might be initially out of the east with increasing clouds and then rain. And you can anticipate maybe a warm front is coming. When the warm front passes, the wind abruptly, in a matter of minutes usually, switches from being from, say, the east-southeast to being from the south or southwest. And suddenly the temperature rises. It's not warm before the warm front gets there. It's warm after the warm front passes because then you're in the warm sector. And with the cold front, last night I was out walking the dogs and there was this warm, balmy. In fact, I knew the storms were going to be bad because it was so charged up with moisture and warmth, a lot of energy pent up. And it was coming up out of the Gulf of Mexico like that. And this cold air was coming around and plowing to it. Last night, shortly after those storms came by, and the tornado that was a post apparently right over my head, and I couldn't find the damage. I heard something though. Suddenly the wind switches to the northwest. This is the way it is in the mid-latitudes. A warm front passes. You get to spend a day or two in the warm sector, maybe. And then the cold front comes and it happens all over again in this endless sequence of a little bit different incarnations of low pressure systems. Now, this is if I live in Atlanta usually. In Atlanta, since we're kind of more like almost to the horse latitudes and kind of well south of the subpolar low, we tend to get the fronts come through. But imagine you spend your life here and you're so used to these fronts and you move up to, say, Minnesota, which is often north of the storm track, where the lows often travel south of you because they tend to go kind of across the middle of the country on average. Then maybe you live here. And what you'd find, I'll live a little further south. Maybe you live here. And before the thing gets to you, you've got, pretty much winds out of the east. And, this ain't your home, but hey, weather's weather, right? So you start telling all your new Minnesota neighbors, there's a warm front coming. And they look at you kind of skeptically like, you think so? You ain't from around these parts, except they don't talk. I don't know how they talk in Minnesota when they say you ain't from around these parts. But anyway, they don't say you betcha. Unless they're being sarcastic. Because look, the wind's out of the east, and you tell them it's going to get warm the next day. You tell them it's going to rain because the warm front's coming, and then it's going to get warm the next day. Joke is on you, and you should have known it. Because the next day, instead of the wind veering around from the east-southeast to the southwest and making you all balmy and warm, instead of that, the wind pulls a fast one on you, it starts backing on you. And it doesn't get warmer. It actually starts to get colder. The pressure's dropping because the low pressure is getting close. But you don't even get a frontal passage. The front never even passes. And then you end up back here in the cold air anyway. The wind backed on you. It backed on you because the low went south of you. You did not ever have an abrupt pressure change. You did not have an abrupt temperature change. You had a gradual change of getting colder and colder and finally probably clearing out after all, but with no real frontal passage. So that's the difference between a wave cyclone passing to you north, where you get the fronts, like we usually do, and passing to your south. Now, they do get fronts in Minnesota too, but sometimes we get the front and they don't, because they're all north of the whole business. There's one other possibility I want to mention, and that is sometimes this low pressure system is so wound up that, and a lot of things are similar in the picture, but not everything. The low pressure is so wound up that you have an occluded front that has both kinds of teeth on it. It's got round teeth, but it's got sharp teeth in between. And there's your low. Because what's happened is this cold air mass, like a cookie on the cookie sheet, is caught up with another cookie and they fuse together. And where's the warm air? It is hidden, occluded. It's been taken up. Nowhere to be seen at the surface. I mean, it is way down south here. But anyway, this is an occluded front. What's it like for an occluded front to pass? Okay, so the wind circulation around the low is like this. The thing is, before an occluded front gets to you, you probably think a warm front is coming. It's like the warm front's coming. You tell all your friends and neighbors that a warm front's coming. It's going to get warm the next day. In fact, everything about it looks like a warm front's coming. The same cloud progression, cirrus, cirrostratus, altostratus, thickening up to nimbostratus, starts raining. Winds out of the east, pressure's dropping. You think a warm front's coming, right, from experience? But look what happens. Right at the moment the warm front's supposed to be passing, it just goes back to cold again without ever getting warm, because the warm air is all up above you. And that's kind of a pulling a fast one on your trick there, isn't it? So the wind would abruptly shift from like east-southeast to like west-northwest or something, west. And I've seen that happen lots of times. It's kind of like the whole business of frontal passages, but with no real temperature change. Maybe a little cooler, maybe a little warmer. Neither one, probably. By the time a low gets to that stage, it's kind of dissolving. The differences aren't really there anymore, and really all you end up with is just a disembodied swirling chunk of air, a low pressure system on its way to its atmospheric grave. There, I've been trying to describe frontal passages and what the wind patterns are like, what the pressure patterns are like. I wish I had the weather cycler. There's some sort of case study thing in the book, and some of the questions I've given you, there's something like that. I think we should talk more about that on Zoom. I want you to be weather-wise so you can recognize these things and what they're like. By the way, in the southern hemisphere, they look all weird, you know. In the southern hemisphere, you'll have a low with the wind going that way. And those Aussie weather maps will have like a cold front coming up out of the light. You know, you'll have a warm front doing that. It looks all weird to me. But anyway, that's what's out. I'll stop with that for now. We do need to talk more about this on Zoom. So there we go, another video. Might be it for chapter 9, but more Zoom talk.